Balancing chemical reaction is one of the popular techniques that we use in order to make sure that every reaction that we come up with is actually producing the right result in the right amount, right? So on paper, we need to be able to balance the chemical reaction so that we can use that. We'll be using that to calculate an amount of reactant we need to mix and the expected output that we're having. So balancing chemical reaction is a common thing that you need to know as a chemist. It's a very common thing. It's a very good technique that we need to understand. The major rule among all the laws that we learned so far, the major one that will help us is the one that is given by the Lavoisier, which says that in a chemical reaction, the mass of all reactants is equal to the mass of all products. So that's the basic thing that we'll be using in order to balance our chemical reactions. So let's quickly go into that and actually learn through practice here. So in all the reactions, right, we said acids react with bases, right? Acids react with bases to form salts and water. That's fine. So we have an acid here, an example of an acid here, H2SO4 is an acid. Then we have another base here, MgOH2, right? So we need to be able to write the right output. So we are supposed to have water and what salt. The water we will have is H2O, and then as well as what the salt. So for the salt, we need to get the dark and the anion part here. So those two come and give us so H2O plus. I could have written it here, but then I need space, so I'll write it down here. MgSO4. So this is the salt that will come out as a result of that. So you need to now balance it. This is not balanced. We need to actually look at how to balance it. Maybe it's balanced, but then let's look at the technique. So first, you take elements by element. Okay. So let's see. On the reactant side, this place is the reactant side, the other side is the product side. On the reactant side, first let's start with hydrogen. How many hydrogen are we having here? We're having 2, and this side we are having a 2. See, we have OH in brackets, right? And there's this 2 outside. So this 2 is actually multiplying. So hydrogen is appearing once. If nothing is written there, I say it's always 1, right? So 2 times 1 here. So from here we are having 2 hydrogen from here, and from H2SO4 we are having 2 hydrogen from here. So on the reactant side, in total we are having 4 of hydrogen. We are having 4 of hydrogen. So on this side, how many hydrogens are we having? So we are having 2 hydrogen inside water on the product side, and then H2SO4 there's no hydrogen. So we're having 2 here, but meanwhile here we have 4. So how are we going to make sure that we have 4 on the other side? Because the law says that was the total number of reactants should be equal to the total number of what products. So to get our product, we have H2O. What you have to do is you need to multiply this by 2. So I'm going to multiply this thing by 2. So make sure that what you are using the factor you are introducing to multiply is actually against the entire molecule. So here there are 2 molecules of what? Hybrid. Two molecules of water. Basically, this 2 is multiplying this H2 to give you 4. So on the reactant side here, on the product side here, we are having 4 hydrogen in total. So remember, we are just focusing on hydrogen. So there are 4. And over here too, we are also getting 4. So 2 here and 2 here, because these 2 multiply this bracket to give you 2 hydrogen. 2 and 2 on the reactant side is giving us 4. So hydrogen is balanced. Let's look at the other substances as well. So the next thing we'll be focusing on is oxygen, right? So the oxygen, how many do we have here? How many oxygen do we have here? We have 4 here, and then 2 here as well, because these 2 multiply this bracket. So 4 plus 2, that's giving us 6. But how many are we having on this side? How many are we having on this side? So we have these 2 that we introduced when we are trying to balance hydrogen, right? Since it is against the entire molecule, this 2 is also multiplying the number of oxygen here. The number of oxygen here is 1. If nothing is written there is 1. So it's going to give us in total 2 here. So we are going to have 2 oxygen from water and then 4 oxygen from the MgA. So there is 4 here, and then sorry. So there is 4 here, right? There is 4 here, and then over here there are 2. So at the end of the day, oxygen, we have 6 oxygen over here as well, meaning after the arrow. So we have 6. So oxygen is also balanced. So 6, 6. Now let's look at the other guys. The other guys are magnesium. Magnesium, how many magnesium do we have here? We have only one, and on the reactant product side, we also have one. So that one is also balanced. Sulfur is one, and then sulfur is one as well over here. So this is balanced. Basically, this is what we have at the end of the day. So H2SO4 plus MgOH subscript 2 will give us 2 molecules of H2O plus MgSO4. Yeah, so this is the basic thing you have to do. But then, yeah, we took the elements one by one, right? And we did that. But when we are balancing stuff like this, especially acid-base reactions, you need to actually make sure that you balance the salt first. You go to the salt, you balance it before you come to the water. Water is the last thing that you need to do. Water is the last thing that you need to focus on and balance. For example, when I started with hydrogen. Hydrogen is inside water, right? But the right thing you have to do, the best technique, is to make sure that you go to the salt, you balance the salt before you come to water. Okay, let's look at another reaction. So one of the reactions that we learned is that acid reactive was source of carbonate to give you what? To give us carbon dioxide, right? Salt. So the salt will be what? Mg CO3, right? And what? Water. Carbon dioxide, water, and then Mg. So these are the products that we learned. We learned this already when we say the common reaction that you need to know. So this an acid reactive sort of carbonate to give you carbon dioxide, water, and then the salt. And the salt in this case, MgCO3. So we are going to start balancing from the salt side. So the salt is not MgCO3, it's going to be MgCl2, because this magnesium need to combine with this, right, to give you your salt MgCl2. Now let's start balancing. You have to balance from the salt side. So from the salt side, we are having how many magnesium here, right? The magnesium, we are having one magnesium and one magnesium here. That's cool. Now let's go to the chlorine. Chlorine, we are having how many chlorine here? We are having one chlorine here on on this side. And if you look at the product side, how many chlorine? We are having 2 chlorine. So to have 2 chlorine and you have 1 chlorine here. So we need to do something. We need to multiply this side by 2. If we multiply this side by 2, then what's going to happen is that we are done balancing the chlorine as well. So we talk about this. We balance magnesium. We just balance chlorine, right? So we balance chlorine. Let's look at the other ones. Carbon, how many? I'm having 1 carbon here and 1 carbon here. So that one is also balanced. Now let's go to the oxygen. Oxygen is how many here? 2 plus 1, 2 here and 1 here. In total, we have 3 oxygen at the product side. How many do we have here? We have 3 here, so it's okay. It's fine. So it's 3. 3, 3, so it's balanced. What about the hydrogen? The hydrogen, we have 2 here, and then we have 2 as well, because these 2 multiply this. So by the time you are done multiplying, balancing the salts, and you are getting to the water, you go to carbon dioxide and come to water, the final one will finally be balanced, so it will match. That's why you need to actually begin balancing the salt. So we are done balancing this chemical reaction as well. We have this one. We said metals react with oxygen to form what? Metal oxides. So the metal oxides that we are going to form here is zinc oxide. Zinc oxide will be the one formed here, right? So now what will be, let's balance it. Zinc is 1, so it's fine. But what's happening to oxygen? Oxygen is 2, but oxygen is 1 here. This one is low. So what you have to do is you have to multiply this by 2. So because this is 1, you need to multiply the molecule. You have to, the number you are introducing should be on the side here. So you have to multiply everything. When you do that, what's going to happen? So when you do that, what's going to happen? 2 moles of oxygen and then 2 molecules of oxygen. Now, see what happens to zinc. Zinc is now 2 now, because these 2 affect all these 2, right? So this zinc is now 2, but zinc is 1 now here. So what I do is I just quickly multiply this side also by 2. So I have 2 zinc, 2 oxygen, 2 oxygen. Then it's balanced. Another chemical reaction is acids react with what? Metals react with acids to form salt and hydrogen gas. This is a common way of producing hydrogen gas. So this is the salt that we produce, and then hydrogen gas will also come out. So let's start balancing from the salt. The salt, zinc is 1. Chlorine is 2 here, and then HCl, chlorine is 2. I need to multiply this by 2. When I do that, now chlorine is balanced. Let's look at the hydrogen. The hydrogen is 2, and then hydrogen is 2 as well over here, and it's also balanced. So this chemical reaction is simply balanced like that. Next one, hydrocarbons react with oxygen to form what? We say to form carbon dioxide and water. So if you balance this, let's start balancing. You are going to start balancing from carbon, right? Carbon is 1, carbon is 1, so it's good. Let's go to oxygen. Oxygen, how many oxygen do I have? I have 2 oxygens here, but over here I have 2, then 2, that's 3, that will be 3. So so there are 3 here, but there are 2 here. But then since I can easily multiply one by a factor to get the other, so let me go to hydrogen and come back to oxygen. So if I go to oxygen, I'm having let me go to hydrogen. Hydrogen, there are 4 hydrogen here, right? So there are 4 hydrogen here, and then there are 4 hydrogen on the reactant side. Over here too, there are 2 hydrogen. There are 2 hydrogen, so I can multiply this side by 2 to quickly get back to 4. So I will multiply this side by 2 to quickly get back to 4. So the hydrogens are balanced. But then what happens? If hydrogens are balanced, what is going to happen to the oxygen? Oxygen is not balanced, right? Can you see that? This is not balanced. I go 2 times oxygen. The oxygen is going to over here. This 2 multiply this oxygen will give you 2 oxygen here and another 2 here, right? 2 plus 2, that will be 4. 4 oxygen is from the product side. In the reactant side, we just have 1. Yeah, we have 2, so we need to multiply this side by 2 as well to get to 4. So we now have 4 oxygen in total, and at this side we also have 4 oxygen in total. So that's the balance equation for this particular one. So it's just a game. We play around this, applying the law of conservation of matter all the time, right? So this one too, if you have hydrocarbon and oxygen, the same thing, you produce carbon dioxide and water. And let's balance the carbon. The carbon is 1, carbon is 1, so we are cool. Let's go to hydrogen before to come to oxygen. So the hydrogen are how many? 6 here, 6 here. But how many do I have? I have 2 here. So I have 2 here. So what should I do? I need to multiply this side by 3, right? To get 6. So I'll multiply this side by 3 to have 6 of hydrogen and 6 of hydrogen here. So that's also balanced. So let's focus on the oxygen now. The oxygen, how many? 3 times 3 times. So there are 3 oxygen from water here, and then there are 2 from here. That's going to give me something like 5 of them, right? But how many do I have here? I have this 2 over here. Remember, we need to always be multiplying. But then let's look at something. The carbon is also not balanced. You see that carbon is not balanced. There's one carbon here, there's 2 carbon here. Wow. So always be checking which one is not balanced, which one is not balanced. So carbon is 1 and this carbon is 2. It's not balanced. So how do I make sure that this guy also balanced? I need to multiply this by 2. So I now have how many carbon? 2 here and 2 here. So carbon is also balanced. So carbon is balanced, hydrogen is balanced. It's left with oxygen. Let's restart for the oxygen again. For oxygen, we said we are going to have what? 2 times this, that's going to be 4 oxygen from here, and then 3 times 1, that's 3 here, right? Yeah, 3 times 1, that's 3. That will give me what? 7 of, yeah, 2 times 2, right? That's 4. That, yes. So we have 7 of the oxygen here, but how many do we have here? We just have basically 7. We have 7 here, but then here we are having 2. So since we have 7 here, what I'm going to do is that I'll try to make sure that this guy is now 7 over 2. I multiply this side by 7 over 2. So when I multiply this 7 over 2 over here, right? These 2 will cancel this 2 because 7 over 2 times 2. This one will cancel this, and I'll have 7. So then it will be balanced. But however, you have to make sure that when you are multiplying stuff like this, the coefficient is not a fraction. You have to make sure that the coefficient is not a fraction. So how do you do that? I need to multiply through. You need to multiply through by 2 so that this fraction will go. You need to multiply through by 2 so that this fraction will go. If I multiply everything by 2, I have 2 mole of C2H6 plus 7 moles of oxygen going to give us 4 moles of CO2 plus 6 moles of H2O. Remember, we were able to do this multiplication by the 2 because we are having a fraction here. Whenever you are having a fraction, make sure that you multiply by a factor that will cancel the denominator. But that thing should multiply through every component or every element, both product and reactant side. That's what we basically did right now, right? Yeah, this is how to balance chemical reaction. Always applying the rule and looking out for how to make sure that each component on either side, right, are equal. So we sum all the, if you focus on one element, you sum all the components on the right side, and then you make sure it's equal to the one on the left side, and you have your equation balanced. After you make sure everything is done, and also look at for fractions. When you have a fraction, make sure you multiply by the LCM to make sure that everything throughout, all the coefficients are balanced. See you in the next session.